Hi, today I'd like to talk about the path of light through different media. But before we do that, I'd like to talk about a few things relating to light. Light is made up of photons. Photons travel at the speed of light, which is the fastest in a vacuum. However, if it's going through other media, it can slow down. Now, one of the other important things is that the photons that take the quickest path will be the ones that are observed, and the others are generally canceled out due to interference. This is explained quite well by Dr. Richard Feynman in his theory of quantum electrodynamics. So that means then, if light is traveling through a medium where it goes slower, it will actually try to take the shorter distance through that slower medium, even if it means taking a longer distance overall, because traversing the slower medium more quickly will reduce the total time that it takes. So to illustrate this concept, what we're going to do, we're going to assume that we have a light source here, and it's going to go through medium A and then cross over at this point to medium B at an observer. The angle which it will traverse a surface from A to B, that will be what we're trying to find, or actually we'll be trying to find the path. Okay, so essentially we have the source here. We have a fixed distance, vertical distance y. We have a fixed horizontal distance x. Okay, and also the distance going up to the surface to where it crosses over, we call that b, and naturally the remainder of the distance is y minus b, since they both add up to y. Similarly, the horizontal distance where it breaks the surface, we'll call that a, and then the rest of the distance which it travels horizontal to get to the observer, we'll call that x minus a. Now, it's also important to figure out which are the constants and which are the variables. So y is not going to change, and neither is the thickness of medium A and medium B going to change. However, the horizontal distance A, that's the one which can vary depending on the medium, and naturally x minus a will also change. So what we're going to do, we're going to represent the time that it transferred the medium as t sub a plus t sub b. Okay, we're going to take the derivative of that with respect to a. We're going to set that to 0 to find the minimum, and then see what we get from there. Okay, so the time that it takes to traverse through A, I'll call that the speed of light through A. We'll call that the time is basically the distance divided by the speed. So it's 1 over c sub A times, I'm going to use a Pythagorean theorem. So it's going to be the square root of a squared plus b squared. Okay, times, okay, a squared plus b squared, and to make it easier for myself, I'm just going to raise that to the 1/2 power, same as taking the square root. And I'm going to add the time that it takes to traverse medium number b, which is 1 over speed of light through b. Okay, again we're dividing the distance by the speed. Okay, and then multiply that basically times distance. So we're saying now that the distance it takes to travel through b is going to be x minus a squared, x minus a squared plus y minus b squared, and raise that to the 1/2 power. Okay, so now I'm going to take the derivative with respect to a. Okay, so dt over dA is equal to 1 over c sub a times 1/2 times 2 times a times a squared plus b squared to the minus 1/2 plus 1 over c sub b times 1/2 times 2 times x minus a times minus 1, okay, because a there is negative, times x minus a squared plus y minus b squared, all raised to the minus 1/2. Okay, so now, and that will all be equal to 0. Okay, since we're trying to find the minimum time. Okay, so the 2 and the 1/2 cancels out here, and same with the 2 and the 1/2 canceling there. Okay, and so what we will get now is 1 over c sub a times a, and mind you, since that's negative, I'm going to be dividing by the square root of a squared plus b squared. Okay, and since this here is negative, I can either put that negative and then set it equal to 0, or I can just simply put the whole thing on the other side of the equation, okay, and get rid of the negative 1. Okay, so it's going to be 1 over c sub b, okay, times x minus a over the square root of x minus a squared plus y minus b squared. Okay, so now that we have that, what we can also do, I'm just going to multiply both sides by the speed of light, and we'll see where I'm getting there. Okay, which is just c. Okay, so now if we look at a divided by the distance, the square root of a squared plus b squared, that is basically the sine of alpha. And similarly, if we take x minus a, which is this distance here, that's equal to that, and divide by that total distance, well, that's the sine of beta. Okay, so we can say now c over c sub a sine alpha is equal to c over c sub b sine beta. Okay, and mind you, c over c sub a, that's basically what they refer to as the index of refraction of medium A. And c over c sub b, respectively, is the index of refraction through medium B. And so now, we can say now, n sub a over n sub b is equal to sine b over sine a, or sine beta over sine alpha. So what we have just derived is Snell's law, which basically is saying the sine of this angle going through medium A over the sine of that angle going through medium B is basically equal to the index of refraction of B divided by the index refraction of A, and vice versa. I have it actually written here, the opposite, but the answer is the same. Now keep in mind that this assumes that we're dealing with non-dispersive phenomenon. Basically, in the real world, the index of refraction will vary with the wavelength. Basically, the shorter wavelengths tend to traverse other media even more slowly, which means the index of refraction is often higher for shorter wavelengths. What this does is that this causes a separation of the colors. It is often referred to as chromatic aberration, and it leads to phenomena such as rainbows. Anyway, that is all I have, and I'd like to thank you very much for watching.